It's me, Mr. Voice. This is our temperature stable chlorate rocket candy. Normally, rocket candy is made of nitrate, but this time we're going to make it out of chlorate and it will be safe as hell. So over here we're going to need about 6 grams of potassium chlorate.
Are you sure that's 6 grams?
There's a weighing scale, don't be stupid.
Oh.
Then we're going to need 3 grams of sugar. That should hit 9 right there. Oh man, I overshot it.
No, it's 5.9.
I'll have to put more chlorate just to be sure. You don't want a crappy mix. Then we need some iron oxide. Put a healthy amount. Now this mixture is totally safe to put on the stove on medium heat. I would say it's a lot safer than even nitrate. Okay, now we're going to need some trisodium citrate. The chemical formula is not really going to help much. I have to give you the structure, but come on, citric acid and baking soda, probably the easiest thing. Or just put an antacid in water and boil it down. Anyway, our final ingredient will be a little bit of cornstarch. And I'm using a different spoon here because I've already touched it. And I don't want some poisonies. Just a little bit. This cornstarch is the important ingredient. Without this, the thing will catch fire the moment I put it on heat. And of course, we need a little bit of water right after we're done mixing this. We first have to mix this. It doesn't have to be mixed well right now, but I'm going to mix well anyway because we need to test the solution's reactivity. If it fails this test, you can turn off the weighing scale right now. I said off, not on. Well, screw it. So after mixing, we have to get a little bit of this and test with our lighter if this mix is a failure or not. You have to put it at the very edge. This will work because it burns at a reasonable rate. Okay, now we add a little bit of water at a time until we get a pasty solution here. I'm using the behind to mix it because I don't want it to get stuck on the spoon. Pasty or slightly powdery solution, like the wet sand look. That's what we're going for. Both of it doesn't matter as long as it's not syrupy. This will take quite a bit of mixing to fix. So just bear with me. There is no hypochlorite in this, so rubbing it with your shirt is completely fine. Put more water. There you can see it's time to turn orange. That's what we want.
Orange.
Now then, we want our stove in medium heat. We want to lower it once we put it in. All you do, you start pouring this in, start mixing it as fast as you can. You will have no chance of any sort of explosion here because everything is safe. I've tested this off camera and on camera. As you can see right now, this mix will let you know if it will blow up by first decarboxylating and giving you a black powdery sludge looking thing. So far that isn't happening, which is a good sign. All you really gotta do is just keep mixing it around. If this was normal chlorate mix right now, this stuff would have blown up by now and I would have gotten myself a nasty fire. But as you can see, everything is completely fine, and we're actually getting it now down to some kind of workable paste. This is different from nitrate-based rocket fuel. That stuff does not get down to something like this. Instead, it becomes a sort of now what you want to do after this is you want to take it off heat, because this stuff doesn't last forever here. Temperature is a little too high, in fact. For videoing purposes, I put the temperature higher than normal. Anyway, this is the consistency you want right here. So what you can do is, you can then take a little with your hand, start rolling it up like this, make a couple at a time, and I'm just gonna leave this on here. You see, you can neglect this as much as you can. It will be absolutely fine. There's no chance in hell it will go off. What you can do is, you can put this off right now, light it up, just drop it in the floor.
Oh, where did they go?
You see, it's a great rocket fuel. Okay, this is a test to see how stable this thing is. Now if you just leave it on here, it will take its sweet ass time before finally bursting in a fiery, fast deflagration. It's really taking its sweet ass time, and there it goes. Now I'll compare that to a bogey mixture of just potassium chlorate, sugar, and water. As you can see, immediately it bursts into flames. And this one's dry, that's wet. Now I'm gonna do another test. I'm gonna do the same thing with this thing, but I'm gonna mix it vigorously while it's in here. So I'm gonna keep mixing it. As you can see, it takes quite a while to light up. And you see all that black stuff coming around? That stuff is not igniting. Most of it's still here. It's black as ever. And yes, it still burns. However, when I get the bogey mixture in here, and I start mixing this around, as you can see, every time I try to mix it around, you see I'm being trailed by I was being trailed by a fiery trail of sparks. And that's the difference between this mixture, and this is why it's safe. As long as you continue mixing this mixture, it'll be completely fine. You see, this black stuff is the starch decomposing before the chlorate. So you got a safety insulating layer, if you want to call it that. And that's why this stuff is thermally stable in high temperatures. Without the cornstarch, you'll get this. Immediate ignition. Maybe it's just voice. This is our field testing of our sugar mixture. Boring because this is a rough surface. It's hard for it to get any proper traction.
Yeah.
It starts to point up. Whoa! They bounce, they hurl, they do everything.
Can they
Spin
do
around and they fly. That one went over my head.
Can they do my homework?
Maybe not.
Why not?